Good morning. We shall continue with chemistry. In last class we had completed the remaining concepts of physics and we had started with chemistry. Like we had gone for radioactivity and fusion was completed, right? And we had started periodic table. In periodic table we were left with rare earth elements. So rare earth element. So my question to you people is, as the name suggests, whether these elements are really rare or it is just a misnomer, or why they are called rare. This should be a question. So the question is, why rare earth elements are called rare? Okay. Okay, if you are not giving answer, let me answer you. As the name suggests, these are not rare. Okay, these elements are not at all rare. They are even more in abundance than known elements like gold, copper, etc. As per an estimate, their abundance in earth crust may be 200 times the entire accumulation of gold. So these are not rare. So why these are called rare? These are called rare because these elements are never found in its purest form. These are generally found in the form of oxides, means they react with oxygen. That is why these are also called as rare earth oxides. Okay. To extract them in their purest form is a difficulty. This is because they are found only in traces. So commercial exploitation becomes very costly and requires extreme technology. And to gain that extreme technology is again a very big question for developing countries like India. So we have gone for collaboration with Japan in this regard. China is largest producer of rare earth elements. So where these rare earth elements are used? Okay, so these rare earth elements you can see in the periodic table, the orange one. These are 17 elements in total, yttrium, scandium and all the lanthanides you are finding, all the 15 lanthanides. Okay, the bigger group that is having all 15 elements to be orange is known as lanthanide series. So these lanthanides and yttrium and scandium, these 17 elements are called rare earth elements. In last class we had seen that these are metals. Okay, if you remember the slide, most of these were metals. So these all are metals. That is why these are also called as rare earth metals. So why we are studying this? Practically this should be the part of geography, but often it is seen as part of science, so I am teaching you, though they will be asking you in paper 1, mostly chances are there. So these are used in electronic industry. For example, your touch screen, okay, all sort of consumer electronics have their utility. Apart from that, you name it, they have it. For example, they are used in oil refining industry, they are used in as catalyst, they are used in precision guided weapon with fire and forget capability, they are used in surgical lasers, communication, in developing communication network, etc. So anywhere, wherever you find electronic or critical electronics, these elements have their application. So as I told you, China is the largest producer of these elements. That is why China is ruling the electronics market in the world. Understanding this? So please write this. These are set of 17 elements. These are set of 17 elements in which scandium, yttrium are 2 and lanthanides are in total 15. That starts from lanthanum, that is why the group is known as lanthanide. Okay, please write. So these are set of 17 elements, name these three. Next point. These all elements are metals. These all elements are metals, hence also called as rare earth metals. Hence also called as rare earth metals. Next point. They are not rare. They are not rare as the name suggests. As the name suggests, comma, rather their abundance may be more than the average presence of gold, copper, etc. Gold, copper, etc. in the earth crust. In the earth crust. In the earth crust. Next point. They are called rare because it is difficult to extract them because it is difficult to extract them in their purest form. It is difficult to extract them in their purest form. And also their concentration in ores is very low. Is very low. They are generally extracted and traded in the form of oxides. Extracted and traded in the form of oxides. Hence, they are also called as rare earth oxides. Hence, they are also called as rare earth oxides. Now write applications. Consumer electronics like touch screen, consumer electronics like touch screen. Next, computer and network communication, computer and network communication. Aircraft and submarine, aircraft and submarines. Night vision equipments, night vision equipments. Surgical lasers, surgical lasers. Rechargeable batteries, rechargeable batteries. Precision guided weapons, etc. Precision guided weapons, etc. Next, right? China is the largest producer of rare earth elements. India and Japan have also signed. China is the largest producer of rare earth element. India and Japan have also signed an agreement in this regard. Okay, so please try this question. Okay, let me read. They are asking about rare earth element. China, which is largest producer of these element, has imposed some restrictions on their export. Okay, the first line is correct. Some restrictions on the export was in news at that time. Okay, next point is, other than China, Australia, Canada, Chile, these elements are not found in any country. So this statement at least you could have marked as wrong, because I recently told you, just told you that India is also having a pact with Japan. If India was not having rare earth element, why it would sign a pact? Okay, this is logical, that if there is no abundance of that thing, why we would sign a pact? So second statement seems to be wrong. Okay, so if second statement is gone, you will get one option A and option 3. Now see option 3. Rare earth elements are essential for manufacture of various kind of electronics. This is just a corollary. Okay, third statement is bound to be correct, and first is also correct. So 1 and 3, C is the right answer. I was expecting answer. I don't know if there is technical glitches that I have not got your responses. Yeah, I have got few responses from Anutosh Kumar, Atul Kumar Mishra. C is the answer. But response portal is not working. I don't know if there is technical error. I have got it from the coordinator. Okay, no issues. Thank you for sharing. Now, this question, okay, this question was asked in 2004. We do not find much relevance that this question may be reflected recently because it is way old. But every year you will find a buzz, okay, of cracker ban or use of green crackers during the times of Diwali. So UPSC has not been interested so far, but there may be chance that in coming 1 or 2 years, such sort of question may be reflected again, right? So we should at least know that what elements are used in manufacturing of firecrackers. So you just write the names, I am just writing on board, then try this question, okay? So these are some of the elements which are generally used in making firecrackers. So based upon this, I expect you to answer this question. They may ask that in green crackers these elements are not used. Okay, then let me tell you, in green crackers the concentration of for example sulfur etc. can be reduced, okay, means harmful chemicals can be reduced, but complete elimination is not possible, okay. They are used in lesser quantity, because if they will not be there, how you can expect lightning and sound? People are fond of those things, okay, not fond of environment. Though the Vedas say that Prakriti Rakshati Rakshita, but yes, there is always a competition that during Christmas, during first January, this happens in West. So we will also do. No issues, we should do. I don't know why you are not answering. Answer C is the right answer. There is nothing to think. Okay, now come to pH scale. कोई इशू है क्या रिस्पॉन्स पोर्टल है क्या? Okay. Now let's come to pH scale. Okay, this is very easy concept, but yes, we have to do because it is part of part of the program. Questions may be asked. So what is pH scale? So pH scale is like this, 0 to 14. If something has a pH of 0 to 7, Okay, pH is nothing but a scale. Okay, pH is a scale to measure acidity or basicity. If something lies between 0 to 7, suppose the pH of something is 0.2, okay, or 5 or 5.4, so it is lying between 0 to 7, so this is called acidic in nature. So anything having pH lying between 0 to 7 is known to have acidic character. And if something is having pH between 7 to 14 is known to have basic character. 7 is known to be neutral, neither acidic nor basic. So if value is 7, okay, it is known to be neutral. Now I would like you to focus on PPT just for a second. Just see this, that whatever the things you intake, okay, whatever is part of your food is mostly acidic or slightly basic. For example, apple you are having. Apple is also having some kind of organic acid named as malic acid. I will telling you, okay, or the lemon, it is citric acid. Okay, coffee is having oxalic acid, we will do it. Milk is having lactic acid. So whatever you are having in your diet is mostly acidic or slightly basic. For example, egg. Okay, egg is having a lot of minerals, that is why basicity is there. Okay, so it is slightly basic. And water is your neutral, or it may be slightly basic. Acidic water should not be, is not fit to drink. So are you understanding this? The things which are highly basic, for example soap, okay, mothballs, etc., those are not good for you. Okay, nobody intakes protein by taking protein shampoo in the bathroom. No, it is written protein shampoo, so I will get protein. No, that protein is not good for you. So you have to maintain the pH and the characteristics also. So on basis of this, let's start with acids. What are acids? Okay, I will write acid first, then different kinds of acid. Acids. These are substances which donate protons or hydrogen ions. Proton and hydrogen ion are comparable. Hydrogen ion means H plus, because hydrogen has only one proton, and if it has donated its electron, it will behave as a proton itself. So that is why it is so. If you are not understanding this, no issues. Remember this. There are very less chances that this statement will be asked. Okay, we will talk about in general, but okay. There is a paper called litmus paper. Okay, so acids turn blue litmus into red. So if there will be blue litmus paper, there is a color, and if you will put some acid on it, it will turn itself or terminate itself into red. It turns blue litmus to red. Now these were the definitions as per the needs of chemistry. Now we should focus in general that what can be. In general, if you ask me, in general these are sour in taste. Acids are sour in taste. For example, tamarind you are having. For example, lemon you are having. Okay, so in general these are having SAR test. Okay, acids are of two types also. Acids are of two types. One is your inorganic acid, another is your organic acid. I will write only about organic, inorganic will be just opposite of that, right? Organic acid. In general, weaker than inorganic acid. Okay, so if you compare an organic acid with inorganic acid, organic will be what? Organic will be weaker. In general, found naturally. For example, it will be found in your food products. Okay, and it is manufactured in labs, and most important, they have carbon in them. If something is called organic, it is obvious that carbon should be there. They have carbon in them. If carbon is not there, kahe ka organic? Inorganic, just the opposite. You can write manufactured in labs, generally stronger, etc. Whatever you can write is your discretion. I will just give you example. Examples are hydrochloric acid, HCl, nitric acid, HNO3, and sulfuric acid, H2SO4. Okay, these are some common acids. So please copy this, then we will talk a bit more about organic acids. Because organic acids are in daily use. These acids are, very rarely used. For example, these are used in diluted form at household for cleaning their drainage system. Okay, for example, hydrochloric acid in diluted form. Diluted form means very less amount of hydrochloric acid mixed with water. Okay, so the efficiency declines and it becomes slightly weak. So it is used in diluted form. In concentrated form, they are used as oxidants, etc. in lab, in industries, or by the psychos for acid attack. So let's talk about organic acid, some examples. Okay, I'm just giving you examples, what can be. First is known as formic acid or methanoic acid, whatever you want to say. Formic acid. Formic acid is found in ant or bee sting. Okay, so whenever you find that some irritation in your skin, why? Because when ants or bees sting, they just they just excrete formic acid in your bloodstream. That is why there is some irritation. Acetic acid, all sorts of, it is also known as vinegar. So it is used in all sort of garbage you are eating, for example Chinese food, etc. So vinegar, so Chinese food in pickles, etc. they are used. Lactic acid in milk product or dairy product. Malic acid, it is found in apple. Oxalic acid, it is found in coffee, chocolate, guava. Tannic acid found in tea. Tartaric acid found in tamarind. One more can be there, I missed. Citric acid found in lemon. Actually, remembering the name of acids, okay, in particular is not suggested, right? But if you see the trend of UPSC from the last 2 years, I do not know that where the trend is going, and nobody can predict. They are going too much factual also. Earlier conceptual questions were having their say in UPSC prelims, but nowadays prelims has been very challenging, or you may say that prelims is not about selection, it is all about rejection. So most of the genuine candidates who have good knowledge, okay, also fail prelims. This is only because factual questions have, okay, drastically increased in UPSC prelims paper. That is why we are trying to cover those aspects also, okay, within the given time frame. Okay, time is the constraint. Else I told you that you can read means a lot also, but the idea is we should only focus on the process. So process is that this sort of questions can be asked, etc. There can be some exceptions, and yes, since the gravity of the paper is very less, because very less questions are asked, that is why this much labor from your side should be sufficient. I am not saying that must be, but should be. Okay, now let's move to bases. I have the liberty to change here, so I will change. So bases will be just opposite of this. Substances which instead of donate, you have to just write accept. And it will turn red litmus to blue, just opposite. And instead of being sour, it is bitter in taste. Okay. Now, where bases are used? First thing is, your potable water should be basic. You should not consume acidic water, because whatever the food you are consuming is acidic in nature, and if potable water is also acidic, definitely you can see issues can be there. Second thing is, whenever you are in a party, etc., some people just forget that they are humans. They just eat more than their capacity, and then what happens? Acidity. So they go for buying something, ENO, etc., right? So that is known as antacid. Antacids, anti-acid. So this is nothing but base. So antacid to remove acidity. Okay. So what are some common? First is your baking soda. Some common baking soda. Sodium bicarbonate. Some common antacid, I am just writing the name. So whatever is your ENO, etc., they will have something like this. Milk of magnesia. Magnesium hydroxide. So magnesium hydroxide looks like milk. So that is why the name is. So these are used in antacid to remove acidity. And third is to remove acidity from soil also. It is not only that it will remove acidity from your stomach, but from your soil also. For example, lime is used. Tuna. Lime is known as, lime is commercial name. It is calcium hydroxide, chemical name. Acidity in soil is the product of unsustainable practices, or most of the time what we do in our garden, that whatever the organic waste is there in the kitchen, we just put it in our garden. So organic wastes after decomposition produce humic acid. So that increases the acidity of the soil. So lime treatment, etc., can help in this regard. Okay, now let's talk about salt. Salt is when acids and base react, they neutralize each other's effect, okay, and give you salt and water. So point is, acid plus base gives you salt plus water. So I am going to write a reaction so that you should know about something. For example, there is an acid named as HCl, hydrochloric acid. We have written. There is a base called sodium hydroxide, NaOH. This is known as sodium hydroxide. These two when react will give you NaCl plus H2O. H2O is nothing but your water, and NaCl is known as sodium chloride, and sodium chloride is the table salt or the common salt you use. Now we shall discuss what are the applications of salt, okay, where salts are used. So I will talk about some bodily function rather, because salt has more importance in your body, in your body. For example, sodium, salt, etc. have their importance. So I will be telling you right now. Okay. First is your in neuron transmission. Application is neuron transmission. So what is neuron? Neuron is looks like this. I hope you know this. So neurons look like this. Neuron is actually smallest unit of your nervous system or functional unit of your nervous system. Okay. For example, your brain, spinal cord, etc. form the nervous system. So these are made up of neurons. Okay. So entire nervous system is nothing but a complex web of neurons. For example, your brain is made up of 30 billion neurons. Okay. It is just an estimation. So there is a complex structure. So any signal is generated, it is transferred from one neuron to other. For example, you make human chain. So human chain from this end to that end. So you just give a packet to first person, the packet will be passed and it may reach to 1 kilometer long if the human chain is that much. In the same fashion, the entire brain is 30 billion neurons, complex web, okay, or network. So neurons transmit signal from one to another. So here the signal is transmitted. So this signal is transmitted in the presence of salt of sodium, potassium and calcium. Mostly sodium and potassium. Calcium is known to be guarding the medium, but you can take it. Okay. So salt of sodium and potassium help in transmission of neuron signal. Okay. So whenever these signals get weak, it means the salt intake in the body is less. When you sweat, okay, a lot of salt come out of your body. Okay. Not only water comes out, salt also comes out. So there is shortage of salt in the body. That is why doctors prescribe that in case of dehydration or excessive sweating, you should intake electrolyte. Electrolyte means either you take a natural electrolyte like coconut water, or you put water and some salt and sugar in it, then take it. Okay, it will compensate for the lost salt in your body. This is what is the suggestion. Okay. Then you must be, have you ever thought that why a person dies? Because of dehydration. The person dies because of dehydration, the salt intake in the body declines. So neuron signals become weak and there is no option for the brain to shut down, right? So this is what is neuron transmission, and here it is used. Second is sweating. So in sweating we have, I told you, salts also come out. For example, salt of sodium, salt of potassium, salt of magnesium, salt of aluminum, everything comes out. You must have heard that some people, or you must have experienced rather, some people have very, different kind of body odor. So this aluminum is responsible for body odor. So if some person changes after coming from office, and if the dog, okay, falls into dizziness, it is all because he is spreading some sort of odor. This odor is because of aluminum. So if you are getting irritated, it means that person is excreting a lot of aluminum. Copy it. Okay, now come to next concept, viscosity. Viscosity is nothing but resistance to the flow of fluid. Whenever I use the term fluid, fluid means liquid plus gas. So liquid and gas are collectively known as fluid. So resistance to the flow of fluid is known as viscosity. Okay. Let me give example. Honey is more viscous than water. Why? Because honey offers more resistance. For example, if you accidentally got your honey bottle broken, so what happens? Honey takes a lot of time to spread, but if it is water, it will spread very soon. Okay. So why water spreads very soon? Because its viscosity, you may understand like chipchipahat, right? The viscosity is very less, but in case of honey, the viscosity is more. So viscosity has some relation. For example, if temperature is increased, viscosity of liquid declines and viscosity of gas increases, just the opposite. You may remember like this, that suppose you have brought some gulab jamun and you have put it in your refrigerator. Next morning you want to have gulab jamun. So when you take it out of the fridge, the entire sugar syrup of that gulab jamun, okay, is very viscous. But when you put it on the flame, okay, the viscosity gets maintained. The concentration of that sugar syrup is reverted back, or you get the same gulab jamun taste. Why? Because you increase the temperature, the viscosity declines. When it is in the refrigerator, it is highly viscous. Okay, you cannot even find that whether it is gulab jamun or something else, bluish sort of thing. So viscosity and temperature have inverse relationship in case of liquid. This is only because cohesive bonds break. I hope you remember cohesive force in last class. So cohesive bonds break when temperature is increased, and in case of gas, molecules come closer. just the opposite. Because in case of gas, molecules are very much separated. They are separated. So when temperature is increased, they gain some energy and they start colliding with each other. So because of that, they come closer, and if they come closer, viscosity will increase. Why viscosity is more? Because density is more. Density means what? Molecules are near to each other. That is why in honey, molecules are more near. That is why it is more viscous. In gas, molecules were away, so viscosity is slightly less. But when temperature increases, molecules come closer and viscosity is increased. So first copy this, then one application we will discuss. Okay, it is winter, so you should wear proper clothes, but some people are heroic in nature. They say that we do not feel anything, right? We do not feel anything. What that mean? That mean that this cold etc. is not going to affect me. So just see that what happens when you come in the classroom in a t-shirt. Last year it happened. So temperature is less, temperature of the surrounding is less, and you are not wearing proper clothes. So temperature of your body will also decline, okay? It will lose some heat from the body and it will match the environmental temperature. So temperature of the body declines. So if this happens, blood viscosity, in the body, it is going to increase because temperature and viscosity have inverse relationship. So if blood viscosity increases, difficult to flow. So blood will find difficulty in flowing. And if blood will be difficult to flow, your pumping organ, heart, right? So your heart have more pressure in pumping blood, and this may lead to heart failure also. This may lead to heart failure also. So that is why you should not try to be hero. Just know the limitations of your body, act accordingly. And there is no harm in understanding that. In teenage it happens, but I guess that you all people are not in your teenage now, but still the behavior is same. Until you just cross the age of 26, 27, there is really maturity gap. But avoid these things, you will learn. Now just see this, then your body also knows that this guy has gone crazy, okay? So you get fever. So fever is the response of your body to save you. So fever is just the response. So when fever is there, your body temperature increases, and if body temperature increases, blood viscosity, which had increased, declines. So that happens, ease in flow of blood. So heart pressure declines, and this is the normal condition. So sometimes, the fever etc. is good for you because that is a response of your body to save you from your Okay, I hope you understood this. Now endothermic and exothermic, okay, very easy concept. Endothermic. Another we are having is exothermic. So I will just do one, okay. If endothermic is done, exothermic is just the opposite. Thermic is something related to heat and endo means input. So here heat is the input. So endothermic reactions are the reactions which require heat to start. So such reactions require heat to start. So in other words, I can say heat is absorbed in the reaction, right? Heat is absorbed in the reaction. So if such reactions are requiring something, some push, okay, so I can tell that these reactions can never be spontaneous. These reactions can never be spontaneous. Why I am saying so? Because these reactions always require some push. Okay, additional heat is required. For example, if you study by your own, regardless of your teachers or mentors questioning you, that whether you have completed this or that, okay, so it means you are spontaneous. And if you rely on your mentor to call you that what is going on, whether you are studying it or not, okay, then this is non-spontaneous. Okay, if you are doing only for the sake of your report card, then this is not a spontaneous thing. If you are doing for the sake of UPSC, it is spontaneous. So that will require a lot of effort. Okay, we can push you, but we cannot get the best out of you until and unless you are dedicated for it. So these reactions can never be spontaneous. And the most important point, if the reaction has completed, right, so the nearby vicinity will be cooler. So nearby surroundings appear to be cooler. After the reaction. Exothermic will be just opposite. I am not going to write. Copy it. We have to cover one important concept before the break. Now let's come to osmosis. So before understanding osmosis, let's understand something. Suppose there are two vessels, sorry, there is one vessel, okay, this vessel, just concentrate upon the first one only, do not go there. So this is a vessel which is divided into two equal halves by a semi-permeable membrane. Okay, it is divided into two halves by a semi-permeable membrane. Semi-permeable membrane only allows the passage of solvent. Okay, so this only allows passage of solvent from solution. Okay, we have done it, that solution is nothing but solute plus solvent, solute like salt and solvent like water. So from the solution, solute will remain on one side and only the solvent will pass. Okay, that is water. Okay, so only allows passage of solvent from solution. This is semi-permeable membrane. Okay, if it is permeable, it will allow everything to pass. So it is semi-permeable, so solute will not be passed, only the solvent will pass. This is what is the idea. Now here in both sides we are having 100 milliliter of water. So here we are having 100 milliliter of water and here also we are having 100 milliliter of water. I hope this should not be an issue. Both sides we are having 100 milliliter of water. Now I did what? I just added 50 gram of salt this side and this side I have added 100 gram of salt. So now if I compare the two halves, can I say that this is comparatively having higher concentration and this solution is having lower concentration? Okay, this solution is having lower concentration. Now just understand like this, suppose you are having two glasses of water, okay, both glasses are of equal size and in one glass you have added 1 tablespoon of sugar and in another glass you have added 2 tablespoons of sugar. So the glass which is having 2 tablespoons of sugar will be more sweet because the concentration of sugar is more. So concentration is defined in terms of solute. The amount of solute is more, concentration will be higher. So here the amount of solute is 100 gram, so more salt is here. So this is comparatively having higher concentration. I hope this part is clearly understood. Okay. So if you will leave it for 1 hour or 2 hours, something will happen. So suppose after 1 hour, what is going to happen? I am going to draw the same vessel. Okay, the same vessel will reflect some changes. So this is again semi-permeable membrane SPM. Okay. This side you will find only 70 ml of water and this side you will find suppose 130 ml of water. Okay. Why? Because from this side solvent will enter to this side. This happens. So osmosis happens naturally. Okay. So after 1 hour, naturally it is going to happen that solvent from a lower concentrated solution passes towards a higher concentrated solution, okay, via a semi-permeable membrane. This is osmosis. So first draw it, then we will write, then we will understand further. Now write the definition first. Osmosis. You want some more time? I don't know actually. Okay. Okay, get few more seconds. If the pace of class is okay, slightly on higher side, please let me know. Okay, inform your coordinator, he will be informing to me, and if you find it to be the pace to be apt, then no issues. Okay, right. Osmosis is the movement of a solvent. Osmosis is the movement of a solvent through a semi-permeable membrane, from a region of lower concentration to higher concentration. From a region of lower concentration to higher concentration. Okay, so this is natural, this happens. So this was lower concentration, so solvent moved from this side to this side. Okay, if you want to understand, then just think that suppose you put resin in water, kishmish, okay, resin in water. So what happens? This resin is sweet, so there is high concentration, and outside there is low concentration. So what happens overnight? The resin swells. Why? Because solvent, the water enters in the resin from lower to higher concentration. So this is what is osmosis. This happens when you marinate your chicken for making biryani. I hope you know how to cook biryani. If you don't, we can have a class on it. I will make you learn 5 types of biryani. No issues. Okay. So you understood this. So whatever the marination process I was talking, so when you marinate with some spices, etc., salt, etc. is there into curd, lemon. So the concentration outside is again what? Slightly lower. But there is something, okay, some good flavor. So that flavor enters in the chicken. So that is why marination process is important. Okay. And that is only because of osmosis. But those who make biryanis, etc., they do not know that this is osmosis. Okay. Now let's move to another concept, reverse osmosis. What is reverse osmosis? So reverse osmosis will be just opposite of that, right? Means from higher concentration to lower concentration if solvent moves. So if solvent moves from higher to lower concentration, that will be beneficial for us, right? For example, this was the solution. Suppose this is lower concentration, I told you, and suppose this was higher concentration, right? So instead of flowing this way, this should flow this way. So this is your reverse osmosis. But don't you think the reverse is not natural? So whatever is not natural is forced. Okay? For example, if there is a gay couple, so gay couple will get attracted to a male, right? But if parents say that what the society will say and what will be the repo of our and how the family will go on, okay, how you are going to have a family, okay, so they will force to marry a girl, but that force will have its own consequences. We do not enter there, that is part of your social issues, but you understand that there will be a force. So here also, if you want just the opposite of it, don't you think it is not natural, so you will have to apply some force or pressure. Generally this is done by a motor. If you want that higher concentration to lower concentration, the thing should go, this will require some pressure. This happens, reverse osmosis is shortly known as RO, that is your RO system of house. That how it works. Let's understand the logic of reverse osmosis, then we will understand how RO or desalinization plant etc. work. Okay. Now suppose municipal water, you want to convert municipal water into potable water. Can somebody suggest me that which will have more salt in it? So municipal water will be having some impurities in it. Right? Municipal water will have some impurities in it, and if some impurities are there in municipal water, it means more salt is there. Means salt intake is there, more salt is there in that water. That is having more salt. Impurity is also a kind of salt. So if there is more salt, it means I can say this is comparatively highly concentrated. So this will have higher concentration, and potable water will be lesser salt, will be having lesser salt, and hence it will be having low concentration. So you are planning to convert municipal water into potable water. So don't you think you will have to apply some pressure? That pressure is seen in the form of motor. So it is RO, reverse osmosis. It cannot be osmosis because you are aspiring to get low concentrated solution from a high concentrated solution. So that is just the opposite of nature. So that is why this is the case. So reverse osmosis definition will be just the opposite. So I am not writing the definition, I just made you understand that why this. Okay. Now just see the PPT. Now we are going to talk about desalinization plant or how your RO etc. works. Okay, so first let's talk about desalination plant, that you want to convert sea water, okay, your ocean water into potable water, or in Delhi etc. like Yamuna desalination plant or Yamuna cleaning plant rather, how they work, because the water in Yamuna is also highly concentrated or impure, so you want to have it. So what are the procedure? So see, the entire setup is having a screening phase, okay, so there is a net, okay, so it is just a net which does not allow the entry of bigger impurities, for example seashell, fishes or aquatic animals, or impurities like coconut, okay, plastics etc. to enter in your setup. So this will avoid those debris or sea creatures to enter in the setup. The second phase is filtering. This is just the phase in which you are filtering impurities like mud, ringworm etc., because those are also the impurities that you would not like. Through the net, mud, hair follicles, okay, ringworms etc. will be entering. You cannot stop the entry of silt, that is mud etc. So that is done away in the filtering phase, okay. So if you remember the question of UV, there was an option of sediment removal. So UV is not removing the sediment, it is the filtering process, because that is mud. So this is done. Then third phase is desalinization. So desalinization is the phase in which what happens? Reverse osmosis happens, that the sea water is converted into potable water. Next process is chlorination. Here the chlorine is given, or ultraviolet treatment can also be given, and then it is sent to your household. So let's understand desalination plant. So write parallelly, that will be the repetition also. First is your screening. Okay. So screening is nothing but net based resistance to avoid entry of big impurities like aquatic animals, debris etc. to enter in the setup. So you would not like that something like this enters in the your plant and the plant is not working, or it is having some flavor of octopus in water. You would not like that. Okay. Second phase is filtering. So filtering is just the removal of minute impurities. Like silt, hair follicles, etc. Third is actually desalinization, or this is the process of reverse osmosis in third phase. Both is here. Whatever you write, both are same. Reverse osmosis. So what is done over here? Here we are having sea water or ocean water. So this is higher concentration. So here there is a motor, or you may write pressure, external pressure is applied, a motor is there, and here you are getting sorry, desalinized water. So here you are getting desalinized water, and some wastewater will also be coming out as you find in your RO. So too much water is wasted. Okay. So desalinized water is here. So in next process, what we do? Chlorination. At your home, UV treatment is given. That is why a UV filter is also there. So this phase is to kill bacteria or virus. So after this phase, desalinized water becomes potable. Because bacteria etc. is also gone. Potable and sent to households. So just see that in third phase I have written the pressure, okay, how much pressure is required. For example, if you want to give water to entire Delhi, a lot of pressure, okay, a lot of energy is required. For example, just look at me. If there is an elephant, okay, sitting at my head, can you imagine the pressure? A mature elephant on my head. If there are 30 elements on my head, yes, you can imagine that even my chutney will not be available to you people, right? Because I will be smashed. A lot of pressure is required. Means this is high energy intensive process. So energy, a lot of energy is required. That is why you should not waste water. Okay, that is your responsibility how you can do this. Because this is energy intensive process and a lot of water is also wasted. That is why National Green Tribunal has urged the government to ban RO in those places where water is potable. But now this has become fashion because of Kent Deta Hai Sabse Shuddh Pani and Eureka Forbes, then Live Pure. Many ads are there and people are, buying for anything. They are not thinking of the environment or long-term consequences because they are not shown those consequences in the advertisement. Okay, so ethical advertisement is also missing. So this is where we will stop. Okay, we'll take a break, maybe 5 minutes. Okay, then we'll start with hydrocarbons. Okay, thank you. Welcome back. We'll resume with hydrocarbons. Okay, and in that the first is alcohol, and in alcohol beverages, distilled, undistilled, like whiskey, rum, brandy, these are distilled, means concentration of alcohol will be more, and some undistilled are beer, champagne, sherry, This is only, okay, don't look like this, I'm not going to teach you these things. Lastly, this is only to just keep yourself motivated. Most of the people find these things to be very interesting. Last year there was one student who has pronounced champagne as champagni, so that is champagne, okay, so do not pronounce like that. So we will talk about alcohol, okay. So whatever I am writing on board, that is your notes. Nothing important in distilled and undistilled. So alcohol is of many types. One is your methanol, ethanol, propanol, butanol, pentanol, hexanol, etc. Many alcohols are there. But mainly we are dependent upon two alcohols, methanol and ethanol. Other alcohols are toxic. This is the only non-toxic alcohol. Okay, only this can be consumed. Okay, only ethanol can be consumed. Other alcohols are toxic in nature, so they cannot be consumed. Okay. Alcohols have their applications in industries. Okay, so alcohols have industrial applications. So where they are used? First as spirits. They are used in cosmetics and paint industries. They are used as solvent. Whatever is not soluble in water is soluble in alcohol, so they are used as solvent also. Apart from that, alcohols are used in blended fuel, which is known by the name gasohol. So what is gasohol? Gasohol is a term used for petrol, okay, sorry, is a term used for two things. One is your gasoline, another is your alcohol. So both in combined form is known as gasohol. 80% of the gasoline is the constituent and only 20% is the alcohol is there. Gasoline is nothing but your petrol. In UK, petrol is known by the name gasoline. So gasoline is nothing but petrol. So why this is done? Why we are going for blended fuel? So this is known as blended fuel, gasohol, as I have written this. Why? Because we are blending alcohol with petrol. So why is it so? So benefits are there. First benefit is reduces dependency upon crude oil imports. Provided Middle East is a very hot bed, right? So crude oil imports can be avoided. See, 20% alcohol if used, alcohol can be made in the country itself by the process of fermentation. Okay, anaerobic respiration. You must have been taught in biology. So this is alcohol. Second thing is, if dependency upon crude oil is decreased, we can say that current account deficit will be decreased because we need to have dollars to buy external things. And third will be less environmental pollution, which is very important. Why less environmental pollution? Because alcohol after burning if alcohol is burnt, this gives you only water and carbon dioxide. So sulfur, oxides of sulfur, nitrogen, which are really carcinogenic and not good for humans and the environment, they are not formed. Only carbon dioxide is there, which is a greenhouse gas. So gasohol is in the list of government's strategy. So copy this. Now there is a slide on chemical explosives. You may not remember these, but often some unfortunate incidents are found, like in Pulwama attack, okay, that some explosives are found, and next day's editorial has some talks on the nature of explosives. So UPSC may question about which of the following is explosives. If you are going to find, then there may be more than 50 or 60 commonly used explosives, but it will be very difficult for you to remember that which is means whether the following is an explosive or not. Okay, there are many complex names, etc. I will just give you a trick. In 99% of the cases, the trick will fulfill its objective. That if you are asked to find that which of the following is an explosive, try to find the word nitro. If word nitro is there, okay, 99% of the chances that will have some explosion characteristics. So for example, dynamite is also nitroglycerol. So everything over here is having nitro term in it. So try to find term nitro. This is what the slide was having its purpose. Okay, let's move. Now we are having solid fuel. Everybody knows. I'm not going to discuss these things. And you must have seen this slide in your class 9th or 10th NCERT. Okay, okay, very old story. So just see. This is known as fractional distillation or fractional distillation of crude oil. Here if you see, this is heated at a very high temperature. Maybe the temperature here is 350 to 400 degrees Celsius, and as we move up, this goes, okay, this cools down. Okay, so upper chamber is having lesser temperature, maybe around 20-25 degrees Celsius, and the lower chamber is having higher temperature, maybe around 350 to 400 degrees Celsius. So what we get different fuel at different temperature. For example, first we get fuel oil. Fuel oil is the cheapest quality of oil that is used in your marine vehicles, for example ships, etc. Then diesel is used for your auto, okay, car, etc. Then we have kerosene is used in aircraft. So aircraft or aviation turbine fuel is nothing but kerosene. So aviation turbine fuel is kerosene, and apart from kerosene more than 2000 chemicals are involved, so that fuel should not get freeze, okay, because aeroplane flies in a very extreme environment. So this is to ensure anti-freezing property, anti-corrosion property, etc. Okay, for this purpose these are added. So that is why these are costly, because kerosene they are used is in pale yellow in color. Okay, kerosene used is pale yellow in color, not the kerosene you use at your home. So this is high quality kerosene, and government impose a lot of tax. So because of that, aviation turbine fuel is very costly. Okay, this was only for your knowledge. So kerosene is used in aircrafts. Then there is naphtha. Naphtha is precursor of chemical industry. So this is the byproduct of this, and this is used in as raw material in chemical industries. Then we have gasoline or petrol, you know what. So I'm going to use 3 fuels over here, and the slide will have only one important function that I'm going to only these 3 fuels. So this is the bottom, okay, then we are getting kerosene, then we are getting petrol, okay, in between there is naphtha, etc. We should not bother. So moving bottom to up, okay, bottom to up, I can clearly say volatility of the fuel is increasing and flammability of the fuel is increasing. What is meant by these two terms? These two terms are very important. Volatility means escaping tendency. Escaping tendency in air. For example, if you put petrol in a bottle and do not put lid on it, same practice you do with the kerosene. After 1 hour, most of the petrol will be escaped or gone out in the atmosphere, and kerosene will also follow petrol, but kerosene will be less volatile, means it will be more in the bottle than in the atmosphere, but petrol mostly it will be escaped. Okay, so that is what is volatility. Second is flammability, means fire catching tendency. So petrol catches fire more easily than kerosene, and kerosene catches fire more easily than the diesel. So that is what is flammability. Now we are going to do one important concept, knocking of engine. Again I am telling you this is part of environment, but it has been assigned to me. Knocking of engine. Have you ever heard unwanted sound? Okay, after 1 lakh kilometer, people often change their vehicle or car. Why is it so? Because they say that this was the age of the engine. Now engine will deteriorate, it will consume more fuel, and it will give you more sound. So when some unwanted sound comes out of the engine, you come to know that it is not in good health. For example, some unwanted sound comes from your stomach, you know that something is upset inside you. Okay, so knocking of engine is what? It is unwanted sound. Coming out of engine. Indicating its poor health. Right? Indicating its poor health. So this is your knocking off engine. I hope you are understanding this. Now suppose how your health is determined. Your health is determined because of your lifestyle. Mostly the food you intake. Suppose the food intake is good, okay, you are having nutritious food, balanced diet, your health is going to be good for longer time. And if you are having the habit of having extra cheeseburger, pizza, okay, garbage like Chinese, a lot, okay, if you are habitual of these things, definitely this is going to affect your health. But if you are having Loki etc. in your diet, that is going to have positive effect on your health. So the same happens with the engine. If the quality of fuel is poor, the life of the engine declines. So in order to ensure that knocking should not be there, means life of the engine should be more, we have to ensure better quality of fuel. Okay? So knocking can be avoided by adoption of better quality of fuel. Okay, better quality of fuel will ensure that knocking will be avoided. So let's understand this. We have octane number and we have cetane number. Right? We have octane number and we have cetane number. So what is octane number and what is cetane number? This is $1 million question. Nothing. Do not bother a lot. Octane number is, it measures quality of gasoline or petrol. Cetane number just the opposite. It measures quality of diesel. Then we have octane number. Higher the octane number, better is the fuel. For example, if your octane number is 90 and octane number is 70, then the fuel having octane number 90 is better petrol. They name it commercially like extra premium. So extra premium petrol will be better than the ordinary petrol because its octane number will be higher. So here same, higher the cetane number, better is the fuel. Last point in both is slightly difficult to understand, but we will understand by different way. The explanation I am going to tell you is wrong, okay, 100% wrong, but the motive is innocent, so please pardon me, because if I go into the details of engine, then octane number have different sort of engine. The entry of the fuel and the oxygen happen at different time in octane number and in petrol engines, and in diesel engines it happen simultaneously. So that will be entering in the domain of mechanical engineering. That is not the mandate of the class. So I won't be focusing on that explanation, and you are not supposed to ask also. Okay. I do not want to enter there. What explanation I am providing you, though it is wrong, but it is very effective in remembering the last point and understanding the last point. Let's understand the threshold. Okay. Suppose a lady is expecting a child. So the gestation period is 9 months. So if a child, okay, if the delivery of the child is before 9 months, it is also not required that premature delivery can affect the health of the child. And if it has been more than 9 months and child is not coming out or delivery is not possible, labor pain is not expected, this is also not good for the health of the child in case of delayed delivery. So if the child is, okay, if the child has to born, he or she should born around 9 months. That is what is general tendency. Okay, else they go for the cesarean, etc., and that is having some other consequences for the mother. Okay, but no issues. Are you understanding this? That time is very much important. Time factor. Premature delivery is also not required and delayed delivery is also not required. I hope this is clear. In the same fashion, suppose if you are putting your engine on, okay, putting your engine on. So at t equal to 5 seconds, your fuel should burn. At t equal to 5 seconds, your fuel should burn after pressing the key. Now issue is, petrol is flammable. Petrol is flammable. इसको खुजली है जलने की, right? It has more tendency to catch fire. So petrol burns at t equal to 4 seconds or 3 seconds, whatever you want to take. Okay, so it is burning before the stipulated time, and diesel is lazy. It burns at 6 seconds. So it is burning, okay, later burning being delayed from the stipulated time. So you would not like this. You would like that petrol should take more time to burn. Here you would like delayed ignition. Right? Or avoid premature ignition. And here you would avoid delayed ignition, or you would like premature ignition. This is what is case. So here ignition is delayed and here ignition is premature. So premature delivery and delayed delivery both are not good. So this is how you remember the last point, that better octane number ensures or just write avoids premature ignition of petrol. So it means, in other words, you can say ensures delayed ignition. And here you write better cetane number avoids delayed ignition of diesel. That is ensures fast burning of fuel. ठीक है, और इसमें स्लो बर्निंग ऑफ फ्यूल, डिलेड इग्निशन मतलब. Okay, I hope you have written. Natural gas. Natural gas is used in two forms. First is compressed natural gas, and second is liquefied natural gas. This is known as LNG, this is known as CNG. LNG. Not used or not in practice in developing countries like India. Despite having higher fuel density. Okay, fuel density is higher than CNG. Means you can go longer distances with equal amount of fuel. Okay, if compared with CNG. Why it is not used? Because India lacks cryogenic infrastructure. Cryogenic means less than 0 degree Celsius. Okay. At fuel stations. So if you want to use this fuel, you need cryogenic infrastructure. So that is not possible in our countries. That infrastructure is lacking. That is why we are not using LNG. Now let's differentiate between LPG and CNG. LPG is full form liquefied petroleum gas, and CNG you are knowing, compressed natural gas, I have written. This is used in gas cylinders at home. And this is used in vehicles, like Delhi is having CNG vehicles and CNG cabs like Ola, Uber. So what are the differences? First is LPG constitutes of gases like butane, isobutane, propane and slightest of ethane, but mostly butane and isobutane. CNG, it is mainly methane. Okay, because it is natural gas. Natural gas is a term used for methane. LPG is orderless. There is no order. CNG is also orderless. You may have questioned that if LPG is odorless, then why in case of leakage we have some smell? So some smell is added so that you should know about the leakage, else there can be fatal accidents, right? So odorless, ethyl mercaptan, when captain dies, mercaptan, ethyl mercaptan is used to add odor so that in case of leakage you can recognize. And here sulfur is added to ensure order. Now, which of the two is dangerous? Yes, you got it right. You must be thinking it should be LPG. LPG is dangerous not because of its fuel density but because of some other property. Okay. For example, LPG is heavier than air. So what happens in case of leakage? Settles at lower places like godown, parking area, etc. So some people may have cigarette and that may prove to be the last cigarette of the day for him and the entire building, because there will be an explosion, because there will be huge amount of LPG. So LPG has the problem of leakage. And just see CNG, it is lighter than air. So in case of leakage, it flushes out in atmosphere. So that is why you have you rarely would have heard about an accident of CNG, but LPG accidents are more common. So please copy this. I'll give you 2-3 minutes. There is one request to you people, that if you have any queries, please put it to the query tab, okay, that goes to the coordinator. Do not put your queries in the response tab. Maybe today response tab is not working, or this is the general procedure. Response tab is only for you people to ask live queries or to give the response to the questions I am asking. Okay. Okay. Now let's move to next topic, that is soaps and detergents. So first let's understand cleansing property of soaps and detergent. Okay. Then we will understand the difference between soaps and detergents. Soaps and detergents. So soaps and detergents are also known as chemistry of surfactants. Why? Because these soaps and detergents, these reduce the surface tension of water enhancing their cleansing properties. Okay. Now if you put soap in water, the soap molecules look like this. It like a matchstick which has its head and a tail. This head is hydrophilic by nature. Hydrophilic means water loving, and the tail is hydrophobic or lipophilic. Lipo means lipid. Lipid is a term used for oil, so you can write it fat loving or oil loving. And hydrophobic means water repelling. So one end is water loving and the other end is water repelling. This is what is your soap. So how soaps work? Okay, the first discussion was this. So first we will understand the working of soap. So you clean water, so clean your clothes in water, right? Suppose this is your bucket, and in your bucket you have put your cloth. So this cloth will have some dirt on it that you want to clean. So this is nothing but accumulation of both dirt plus oil. So whatever the unwanted dirt is there, okay, that is accumulation of mud, silt and oil, because during sweat some oil is also excreted and that sits on the clothes. Everywhere there will be water, right? So this is water everywhere, all around water, because you clean your clothes in water. So now you are putting soap. So soap molecules will do something. It will align itself. For example, the tail is water repelling or fat loving. Fat means oil. So soap molecules, this black one, will align themselves like this. Right? So these are your soap molecules. Now just see, this is the head. So head will be towards water because it is water loving. And this is tail. Tail is water repelling. So tail is towards oil or dirt. So don't you think the entire dirt is captured, like police ने तुम्हें चारों तरफ से घेर लिया है, the same thing, right? So this is known as micelles. This structure is known as micelles, means water molecules trapping the dirt. So this structure is known as micelles. So while rinsing, when you rinse your clothes by water, micelles come out taking out dirt with it. So in rinsing process, the micelles come out of your clothes by taking dirt out. So this is what is the cleansing property. So please copy this, then we will proceed further. In last class we were 15 minutes ahead. Okay, so we had covered last few parts of chemistry. So today also we will utilize those 15 minutes. Maybe we will be just introducing cosmic physics today, if time permits. There is one request, if possible, try to watch a web series named GL50 or a movie called Interstellar. Before coming to the last class, that is day after tomorrow. GL50 will also serve the purpose. GL50 is in Hindi, Abhay Deol, it is easier version. Interstellar is very complex, so whatever you want to watch, because there are some concepts of theory of relativity that has been discussed in GL50 or Interstellar. There are some myths also, and but who knows, and we are bound to study about theory of relativity because UPSC is very much interested in that domain, and this year also linkage of black hole concept with theory of relativity was awarded Nobel Prize. So we are bound to study that. Okay. So I hope you have written this. Now let's move further in the discussion of soaps and detergents. So let's understand the difference between soaps and detergents, and then their cleansing properties are also slightly different. Just see this, soaps are actually both are salts. In simple terms you want to understand, both are salts. These are sodium and potassium salt of fatty or carbonic acids. Okay, and detergents on the other hand are harder. Okay, these are sodium or potassium salts of sulfonic acid. So both are basically salts. Carbonic acids and sulfonic acids are very bigger chain of hydrocarbons. Okay, COOH is the root. We will not enter there. Okay, that will make the class complex. Just understand that these are known in chemistry by these terms. Property of soap is slightly different. For example, soaps are not effective in hard water. In hard or even in saline water. whereas detergents are effective in hard or saline water. Why is it so? So we'll do it parallelly. I'm not going to dictate anything. Now first understand hard water. Hard water is your normal water, that is H2O plus metallic salts. Metallic salt means salt of calcium, magnesium. Okay, calcium carbonate can be there, magnesium something can be there, magnesium, etc. So hard water is normal water plus metallic salts, means salt of calcium or magnesium. There is one more, heavy water, that was used in nuclear things. So heavy water is your deuterium water, isotope of hydrogen. I hope you remember D2O. So please do not get confused between these two terms, hard water and heavy water. They are totally different. This is normal water having some metallic salts, means some impurity. Salt is a kind of impurity. So that becomes hard water, and heavy water is just different. It is D2O, isotopic. This is isotopic water. So what I told you, I told something, na? Soaps are not effective in hard water or saline water. In saline water we will also have sodium salts, magnesium salts, calcium salts, so definitely it will not work. Why is it so? Soaps are like those of some of your friends. If you ask them, go and bring some samosa for me, okay, you were hungry, so your friend went to buy samosa and he found some boys playing cricket, so he was also engaged in playing cricket. He forgot to bring samosa. After 2 hours he came without taking anything and you were hungry. So this is your soap. You assigned a task, but the task was not done. Because when soaps are added in hard water, they react with the metallic salts and hence they lose their cleansing property and there is no foam formation. Understanding this means instead of cleaning the clothes, they started interacting with the metallic salts. So they did nothing. On the other hand, there are few friends, if you ask them to bring samosa, they will bring samosa first, then they will do other activities. Okay? So detergents are like that. They are given the task of cleansing, so they will clean the cloth. They do not interact with the metallic salt. So that is why they are effective in hard water also. In normal water there is no metallic salt, so soaps also work. But in hard water, metallic salts deviate them from their path. So soaps are simple boys and detergents are sakht londa. Have you heard that? Right? So they will be focused upon their job. Nothing can deviate them from their path. So that is the case. So please write after this, soaps are not effective in hard water because they react with the calcium and magnesium salts present in hard water. Because of that, okay, so what you wrote, react with calcium and potassium salt present in hard water, because of which foam is not formed, and cleansing property is compromised. Foam is not formed and cleansing property is compromised. On the other hand, detergents do not interact with metallic salts of hard water detergents do not interact with metallic salts of hard water, and hence they are effective in hard water also. Okay. Now let's focus on few of the terms. Come to the PPT. Okay. And this is the last topic of chemistry. That should be over by 15-20 minutes. Then we will start cosmic physics for 15 minutes. Just the basics, so that tomorrow we are in the game. And in last class we can wrap up very soon. Okay, maybe half an hour before also. So that will be in last class. So that is why we will be utilizing time today. So the first term is phosphorescence. So what is phosphorescence? Try to understand the things, then I will make you write, don't worry, the definitions I will be providing you. Phosphorescence is, there are some materials, for example calcium sulfide or strontium aluminate, zinc sulfide. So these elements have some property. What property do they possess? That these elements interact with white light and they absorb few of the visible spectrum. For example, visible spectrum is having 7 colors. So they consume or absorb some of the visible spectrum. Suppose the green one. So when sunlight will be gone, they will be emitting the absorbed spectrum. This is what is phosphorescence. You may understand it like, I am not saying that moon is working on this principle. Moon is taking all the light, okay, all the visible light. It is not only taking one sort of light, else it was pinkish in color. So moon is also doing the purpose. It is absorbing the light coming from the sun, and when sun is gone, it is dissipating or radiating the light absorbed. Is it fine? So for example, just see this. This is calcium sulfide. So calcium sulfide has absorbed the green color. Because of that, when sunlight is gone, it is reflecting its own color. So this is called phosphorescence. So phosphorescence is slightly, you know what, slightly slower process. Just see, suppose this was calcium sulfide or anything else. So white light was coming. White light means VIBGYOR was coming. And it thought that let me have green color. So it will absorb green color. So from this half you will only get VIBGYOR because G is absorbed. So this happens. So this is in presence of sunlight. Green spectrum is absorbed. So when sunlight is gone, this will be radiating green color. So in absence of sunlight. This is phosphorescence. You must be thinking why we are studying these things. Okay. See, these things are really important. For example, they can be used as guideposts. They can be used in emergency situations. For example, if you have ever been to a flight, the air hostess tells that in case of emergency, phosphorescence guide post will take you to the nearest emergency exit. आपातकाल की स्थिति में प्रतिदीप्तिशील पट्टियां आपको निकटतम द्वार तक ले जाएंगी, ऐसा कुछ. So why she is saying so? Because when there will be emergency situation, so there are high chances that light will not be available or light system of the flight will not be working. So we need some materials of that kind. Those should be emitting light in absence of light source. Okay. So for example, calcium sulfide, so when the light system of the flight is working, they will be absorbing the light, and when that will be gone, they will be emitting their light. So you will come to know that yes, this is the path we have to follow. So you will not be, having any trouble from fellow passengers or the seats, etc. So the aisle will be easily available to you. Now, second thing, have you ever seen the divider stones? Divider stones at NH. So these divider stones at night also guide you that this is your half and this is their half, right? So these divider stones are also of this kind, calcium sulfide, etc. So they just absorb the green color in presence of sunlight, and when sunlight is gone, they radiate their own color. So this is the purpose of phosphorescence or the meaning of phosphorescence. Okay. So please write this. The spelling is on PPT. We'll understand it further after we have done fluorescence. Please write phosphorescence. When any substance absorbs light let me change the statement. Okay, I have just missed something. When substance like calcium sulfide, when some substance like calcium sulfide is kept in presence of sunlight, they absorb some of the visible spectrums. They absorb some of the visible spectrums. When sunlight is gone, they emit the absorbed spectrum. Write the definition of fluorescence also. Last two I will not be dictating because last two are very easy. So next write your fluorescence, then we will discuss fluorescence and phosphorescence together. Fluorescence, right? When any substance absorbs light, the electrons get excited. And change their orbits. In their return journey, in their return journey, they emit radiations of various wavelengths. They emit radiations of various wavelengths. This is comparatively a faster process than phosphorescence. Applications, you write argon lamp. You remember yesterday I was talking fluorescent lamps. So this was the fluorescence I was talking about. Argon lamps, glow sticks, GLOW, glow sticks, etc. One more definition you write, then I will stand and do everything together. Efflorescence, EFFLO RES CENCE. Efflorescence, EFFLO RES CENCE, right. Some salts like washing soda have excess moisture in them. When such salts are exposed in sunlight, moisture fumes out in atmosphere, or moisture evaporates, and salt crystals are left behind. I hope you have written the application of phosphorescence. I had told, actually, if you have not written application of phosphorescence, just write there what you can write. Emergency guideposts, divider stones at national highway. Okay, this you can write as application that I have told you. Now just understand what I have talked about phosphorescence and fluorescence together. Let's make an atom. This atom is not going to leave us. So there is neutron and proton in the nucleus, and electrons are all around. Yeah? Electrons are all around. Now suppose this electron has absorbed some light. So this is obvious that this electron is going to change the orbit, right? But after some time, the adjacent electron will say that you are impacting my privacy, go back to your house. So it will either come back to this orbit, then to this orbit, then to this orbit. This is the first way of coming. Or it may come directly. Second way of coming. Third way of coming can be, it can go to this orbit and to this orbit. So this may be the third way of coming. Yes, this is the mood of the electron, where he wants to go. He has to come back to its own orbit, but the manner or the path it can choose, right? So this happens in phosphorescence and fluorescence both, right? But if it is slow in nature, this will be called phosphorescence. This may go around 6 to 8 hours emission of light. For example, the divider stones, they give you light throughout the night, or the emergency post, they will be also giving you light at least for 4-5 hours, because not all the passengers can immediately come out within 5 or to 15 minutes. So that requires time. So that is why phosphorescence is slower process. And F for fluorescence, fluorescence is faster process. Fluorescence is faster process. It may end up to 15 minutes. For example, I made you write about glow stick. If you ever seen movies like Star Wars, etc., so they are in a cave, etc., so they just glow this stick so that they can know the picture of the cave, that if something is there where they have to keep in keep precaution. So glow stick is to emit sudden light immediately. Or if you are left in an ocean and you have found that a ship is going nearby, so just burn a glow stick so that the sailor should know that someone is there in the ocean, we need to protect them. Okay, so glow stick, etc., is that purpose. So this is your fluorescence. Okay. Third definition, just see there in the PPT. So this is your glow stick. Or the argon lamp. Now see luminescence. Luminescence means any source giving you light, any source, your bulb, the flashlight of your mobile, okay, the laptop, or even ocean. Sometimes ocean also glows. Why? Because of the living creatures inside it. So you understood the third term, luminescence. So luminescence I am not going to tell. Luminescence means any source giving you light. Then we have bioluminescence, the fourth one. So bioluminescence means any living creature giving you light. For example, firefly, Jugnu. Have you heard? Or sharks, they have their own headlight. Jellyfishes, if you ever seen Life of Pi, so jellyfishes were igniting throughout the night, right? So if bioluminescence means living creature giving you light, that is bioluminescence. Mushrooms, etc., they can also emit light. And if it is any being, anything, okay, any source giving you light, that is luminescence. And the last one, the efflorescence, that I have made you written. For example, you must have seen such sort of wall. Where? Such sort of wall? In villages. So in villages there are such walls where salt crystals are left behind. So accidentally, if washing soda like salts are there in open air, so they lose their water and these salt crystals are left behind, and that is what is known as efflorescence. So efflorescence term has nothing to do with light, but since all the names are rhyming, so if suppose UPSC is giving and you get confused, so that is why I have given this, so that you should not get confused, because the name is rhyming like others. Okay. So that is efflorescence. So this is where we have finished our chemistry. Okay. Now I will be starting cosmic physics. I had not thought, okay, that I will be starting it today, but since there is 15 minutes, I told you in last class we were 15 minutes ahead. In every other classes I had covered up to nuclear physics on fission and fusion, but in your class we had started periodic table also. So we are left with 15 minutes that will benefit us in the last class. Okay, we can wrap it soon or we can have further discussion also. So cosmic physics I will be starting. Tomorrow I will show you the agenda when I will be sharing the PPT. But as of now, very simple concepts we will be covering, that what is star, what is planet, etc. That is why I had asked you to study the same. So we won't touch much like asteroid, etc. we'll touch tomorrow, but yes, whatever we can touch today we will do. Cosmic physics is very entertaining, okay. Take it from me, it is tough also. You will be facing some difficulty in understanding also. Not tomorrow's class, maybe day after tomorrow's class. But please do not feel bad or do not feel demotivated. I'm telling you that I will be simplifying it as much as I can. But you will have to revise the things. In one go you cannot, cannot have the mastery over the subject. Whatever the things are there, I will be dealing in the class, and whatever the current developments are happening after the class, you will have to keep the tab on it. Because last year the physics Nobel Prize was in the field of dark matter, this year again in black hole. So you are finding that in last 5 years most of the Nobel Prizes have been awarded in the era or in the field of cosmos. So that is why cosmic physics is having a lot of water. So on that premise, let's start it, okay, and keep patience. Today nothing will be of much value. This is just a revision exercise, because in most of the batches when I go for teaching, geography is not over. So I cover stars, planet, etc. also. Then asteroid, etc. I cover in different domain. Okay. So do not think that whatever you have been taught, the same will be taught. Definitely the perspective of a geography teacher is different from a science teacher. Okay. So if I will be teaching you that thing, I will be teaching you in different manner. Even if your faculty has taught you Higgs boson, my way of teaching will be different, because I will be covering the science aspect and he will be more concentrated on the geology, etc. The another thing is that suppose someone is teaching with environment. If he is geography teacher and if he is a science teacher, definitely the approach will be different. So please do not get bored, etc. Okay, let's start. First is your Newton's law of gravitation. So Newton's law of gravitation. So what the law says, okay, you write parallelly, this is very easy. Okay. The first thing is, any object having mass, okay, any object having mass in cosmos, right, or in entire universe, you write in universe, attract each other by a force of equal magnitude. This force is called gravitational force or force of gravitation. Okay, what it meant from this? Suppose there is an object, this is a smaller object, and suppose this is a bigger object. So what Newton says, that first thing is, this object will be attracting the bigger object towards itself by force F1, and this object will be attracting the smaller object by a force of F2. So first thing he said that F1 and F2 both will be equal, and this will have some mass, because the first criteria was any object having mass. So mass is the first criteria, mass should be there for the force of gravitation to be there. Okay, it is an attractive force. So this is an attractive force. So second important point is attraction, and third is equal magnitude that I told you. So this is the equal magnitude thing. Suppose the distance between them is r. Okay, r is the distance. So second thing is also saying something, that Force is directly proportional to the mass of first object. So bigger will be the mass, bigger will be the force. And the force will also be directly proportional to the mass of this, because mass is important for force of gravitation to act. And third is, more is the distance, lesser will be the force. Obviously, long distance relationship, right? That is again a new funda. So you must be knowing that long distance relationships are very, very difficult. For example, few of my friends who have got into services, so they do not understand the practicality. There is always, let me tell you, there is a question from Vikram Singh. Okay, I will deal it, don't worry. What I was telling you, suppose you get into services, then you think yourself as a different class, a class of officers, class of IAS, IPS. So they get married within their caste. So there is no caste like scheduled tribe, scheduled caste, OBCs, or general, nothing. There is only one caste, officer caste. So they just get married. Now just see, the husband is in Manipur, the wife is in Delhi, husband is in Kerala, the wife is in Gujarat. So there is a long distance relationship. Though they are busy, but if you are getting married, if you are having a partner, you would like that both should be sharing their problems, everything with each other. So the tendency of divorce is also happening, increasing in these couples. There is no personal life. Always in ethics it is taught, personal and professional life should be maintained. But how you can maintain in such relationship? Okay, so that is my thing, that if you are getting married, think the practical aspect of the relationship. Now just come here. So this force will give you Gmm by r square, that was given. So if you do not remember this equation, no issues. Just remember that it will be directly proportional to mass and inversely proportional to the distance between them. So this is Newton's law of gravitation. There is one question from Vikram Singh. Light giving algae in ocean should come from bioluminescence. Yes, that is coming from bioluminescence, but since you are finding ocean to be glowing, so that is luminescence. Ocean glows not only because of bioluminescence. Ocean can glow because of phosphorescence as well as bioluminescence. Okay. So ocean luminescence is not only because of bioluminescence, it can be because of phosphorescence. Suppose there is a rock of calcium sulfide, okay, near the shore. Okay, don't you think that calcium sulfide will be glowing at night? So that thing can enter because of erosion. So this was doubt. Okay. So Newton's law of gravitation we have done. Now the next concept we are touching is escape velocity. Right here only, it is the minimum velocity required to overcome the gravitational pull of Earth by an object. For Earth, escape velocity is 11.2 kilometer per second. Okay. For example, suppose this is Earth. So you must be knowing that there will be a region like the magnets have their magnetic field. Earth will have its gravitational pull. So this is the region of gravitational field of Earth. A circular field will be all around. So there will be gravitational field of Earth like a magnet has its magnetic field. So suppose Chris Gayle hits for a 6. So the ball is bound to come back. Why the ball is coming back? The ball is coming back because it is not having enough speed, okay, to cross this distance. So when the ball is hit, it is pulled by the gravitation of Earth and it is bound to come back. If something has to cross this limit, so it should have enough speed up to this distance so that it should cross it. So that speed required is 11.2 kilometer per second. So if it has crossed this line, okay, if it has crossed the gravitational field, so it is not going to come back on Earth. So this V escape in escape velocity is nothing but 11.2 kilometer per second. So that is given by some circular motions, etc. If you have ever seen Mangalyaan, etc., so you could have interpreted that that speed is required for Mangalyaan to overcome the gravitational field of Earth. So for that, some special velocity is required. So in technology, when you will be taught about satellite, etc., okay, or the propulsion of rockets, etc., then you will come to know about that concept in much detail. Now some definitions. Star. What is star? Star is lump of dust and gas which has its own light. I hope this is known to you. The most important thing, dust and gas, and second important thing, own light. So if you are writing the definition, if you are understanding it, so these both things must be clear to you, that what is star. These are the basic definitions, so I am going a bit fast. Okay, let's finish it here with last definition of the day, planet. From after planet we'll start from asteroid. So we'll start from asteroids tomorrow. So what is a planet? Everybody knows Earth is a planet. So what is the criteria to be a planet? So there are three criteria to be a planet. Every planet must satisfy the three criteria. Pluto failed one of the criteria. That is why Pluto is not called a planet. So that is what we are going to write. The first criteria to be a planet is it should revolve around sun. So this is the first and foremost criteria. It should be satisfied. Second criteria is it should have enough gravity to attain a spherical shape. Spherical means nearly spherical is also possible. It cannot have this sort of shape like the asteroids, etc. is having, right? This sort of shape, etc. is not required. It cannot be entertained. It should have enough gravity to have spherical or nearly spherical shape. Only then it can be a planet. And the third criteria, which is most important, it should have enough gravity to clear off its surroundings. Pluto fails this criteria. What is meant by this? For example, this is your sun, some planet is revolving around it. So the surrounding of this path should be clear. It doesn't mean that it should be getting collided with some particles or some other celestial bodies time and again. For example, if it is Pluto, so Pluto is here, there are many objects here, so Pluto collides with it. It does not have enough gravity to clear off its path or surrounding. Okay, because Pluto falls in Kuiper belt. So what is this Kuiper belt, etc.? We will come to know tomorrow. Okay. So as of now, just know that Pluto fails this criteria. Why Pluto is failing this criteria? The explanation will come tomorrow when we will be covering Kuiper belt. Okay. So this is where we stop today. Tomorrow we will be continuing with the concepts of cosmic physics like asteroids, comets. I will be just revising that very quickly. Then we will enter into life cycle of star. We will be talking about force carriers. We will be talking about heliosphere, interstellar medium, whatever the terms you have heard, black hole, supernova, neutron star, white dwarf, and other concepts. Okay. Thank you.